Hi everyone, let's talk about a puzzle called 25 Knights. In this puzzle, we have a non-standard chessboard. So instead of an 8x8 chessboard, we have a 5x5 chessboard. And we have a knight on each of the 25 squares. So obviously this is not a real life chess scenario. We have way too many knights. But let's say there is a knight on each of the squares. The question is, can you legally move all 25 knights simultaneously so that each knight lands on a new square? And here's the important criterion. You can't have any two knights land on the same square. And the question is this possible? So if it's possible, demonstrate such a revolution. And if it's not possible, prove it. So I'll wait a few seconds. You can pause the video if you want. I'll count down from 5 and then I'll cover the solution. So 5, 4, 3, 2, 1. Alright, let's take a look at the solution. The first observation that we make is that no matter which square a knight sits on, the 8 other squares to which it could move, not only do they lie on a circle, but they all have a different color from the original square. So, for example, in this diagram, the knight is sitting on a black square, and the 8 positions to which it could move are all white. So that's our lemma, and let's see how we can use that. In a 5x5 grid, we have 12 white squares and we have 13 black squares. So specifically consider the 13 black square knights, the knights that are sitting on the 13 black squares initially. If they were to move simultaneously, they would have to go to the 12 white squares. But if you use the pigeonhole principle and you have 13 elements mapping to 12 elements, some two elements in the domain, meaning the original 13 black squares, they have to map to the same square. So there exists two knights on black squares that land on the same white square. Maybe more than two, but two is all we need to form a contradiction. Therefore, this simultaneous move of 25 knights is impossible. Thanks for watching, and I'll see you next time.